All right, algebra kids, here we go. There's a review for the chapter 2 test, and I will try to be swift while yet being very clear. So again, solving. We're solving equations when there are equal signs involved. So that's when we're going to draw our line straight down, and we need to locate the variable, and we say what's with it. Well, subtracting is the same as adding the opposite. So that's a negative 12 there. So opposite of a negative 12 is adding a positive 12. Remember, the signs need to be negative. Now, if you viewed that as a minus 12 and add 12, it's the same thing. But I wanted to just be clear on that. So that crosses off because negative 12 plus 12 is 0. I'm left with my x still on this side of the line. And 8 plus 12 is 20. Going over here. Draw your line, circle your variable. What's with it? The 6, you look before the number and see what it is. It's a positive 6. So I need to do the opposite, which is add a negative 6 or subtract 6. Same thing. Gone. I'm left with the a over here, and 33 minus 6. Got to do a little subtracting here. 13 minus 6 is 7. 2 minus 0 is 27. Now, in the next one, notice there's two verbs. Write an equation to represent the relationship, and then solve. So we got two different things, so of course there'll be 2 points in here, but you're going to write a number decreased by 9. So remember, a number is like your x. So x decreased by, that is a subtraction, 9. Is equal, that's equal to 6. So I've got my equation right there. Now I have to solve it. Draw your line, circle your variable. So I'm going to do it a little different. So up here I said you can change it, right, to adding the opposite. And so I want to show you the other way you can look at it too. You can say, oh, I'm subtracting 9, so I'm going to add 9. X is equal to 15. Okay, very good. And remember, the only one that's a little tricky is if it's less than. Remember, a number less than 9 would be actually 9 minus x. It flips the direction of it. But that's only when we use those terms that it flips around. All right, we're going to solve now. We're going off from adding and subtracting to multiply, divide. So you still draw your line, locate your variable, but again, the operation between these two is multiplication. So the opposite of multiplying the m by 8 is dividing it, and I show the dividing with a fraction bar because it means the same thing. And what I can see is I want to get rid of that, so it's going to be an 8 there and 8 there. 8 over 8 is 1. So I'm left with just the 1m, or m, and 56 divided by 8 is 7. Okay, over here, draw the line, locate the variable. And again, it is multiplying, so it's a fourth times x. So we would think, oh, we're going to divide then by a fourth. And we think, yuck, right? A fraction divided by a fraction. But we know, and you've learned, that multiplying by a fraction, dividing by a fraction is the same as multiplying by the reciprocal. So I'm going to multiply by the reciprocal of that. Go to the other side, multiply by the reciprocal. And remember, 4 over 1 is just 4, so I don't necessarily need that part, but you can put it there if you'd like. These cancel, cancel, cancel. You're left with 1x, but you don't have to put the 1. And negative 6 times 4 is a negative 24. Make sure you're clear on your rules with adding and subtracting and multiplying, dividing negative values. On we go, and we get to do another one like this where there's two verbs. We're going to write, and we're going to solve. And I'd like you to try to get in the habit of circling those verbs so that you don't forget part of it. Write an equation to represent the relationship, the product. So product means multiplication of, now it's going to tell you This of triggers you to tell you the two things that are getting multiplied. The product of 6 and a. So I can write that as 6a is, I think I wrote that backwards. The product of 6 and a number is 24. I don't know why the word numbers in there, but it's okay. So that is the equation. I have an equal sign, so I have an equation. Draw your line, locate your variable, and now you're like, oh, it's 6 times a. Opposite of multiplying by 6 is dividing by 6, which is equal to 4. Okay, more solving down here. So the techniques are the same, but it just gets a little more complicated. You still draw your line, you look for your variable, and yes, there is only one in here. Sometimes we're going to end up with some on both sides. But first thing you need to do is get rid of the parentheses. So as soon as you see that, and if this was a number in here, like 8 minus 5, well, sure, I could just subtract them and get 3, and then multiply by 3. But it's a variable. So I need to use the distributive property, or the spider legs, and you multiply 3 times p, which is 3p, minus 3 times the 5, which is 15. So I just dropped that minus right in there, and then it's just a straight up multiplication for the other two. I'm going to rewrite the rest of it here. And now, good, the parentheses are gone. So I'm still not quite ready to jump up to these types of problems, or the ones above. I still have my line here, and I want to look at all these. I have how many terms over here? I've got 3 terms. And how many are like terms? These two, correct. So we got a negative 15 and a positive 8. So when we combine negative 15 and positive 8, what do we get? Negative 7 is correct. Now we're back to a 2-step solving problem. So we got to get rid of the 3, and we got to get rid of the 7. But remember, it's opposite of PEMDAS. So we work ourselves back up. So we do all adding and subtracting first. So I need to do the adding and subtracting part, which is right here, before I do work with the multiplying, dividing, which is here. So I'm going to add 7. Cancels out, and I get 24. Now I'm going to deal with this. It's 3 times p. So I'm going to divide by 3, and p is equal to 8. So, okay, one more on this side, and then we flip it over. Draw the line, locate the variable. Again, we have 2 different things. We got the 3 and the 2. Opposite PEMDAS. Add, subtract first. So we got minus 2, so we're going to add 2. C over 3 equals 17. Okay? Now I have C divided by 3. What's opposite of dividing by 3? Multiplying by 3. So we're going to now multiply by 3, and I'm going to be left with 51. All right, one moment. I have to go do a quick errand. All right, I'm back. Thought I'd change it up a little, get a little blue pen going here. So we got this painting company. This painting company charges $250 base plus 16 per hour. So what that means is straight up you're paying $250 no matter what. And then you're going to pay also $16 per hour. When we get another painting company that charges $210 base, and they're $18 per hour. So this one you're charged more at the beginning and less per hour, and this one's less at the beginning and more per hour. So you're trying to figure this out, like how long is a job for which the 2 companies cost the same, right? So the same means equal. So it's kind of cool though, because you can do this like with cell phone plans and stuff like that to figure out, well, at what level do these 2 plans balance out? So you can kind of figure out which one's the better deal. If I know this job isn't going to take 2 hours versus 7 hours, it would probably depend. So let's see. We got $250 base, straight up, plus 16 per hour. So I'm going to make X be my hours. And I'm going to say plus 16X. Now I'm going to set that equal to the other company, which is 210 plus 18 per hour, which is X. I'm going to solve, and this is going to tell me at what hours they're the same. So first off, I look and I see I've got a variable on both sides. So I need to get these together. It's the easiest if you move the smallest one. So I'm going to move the 16X to this side. And I'm left with 250 over here, 210, and 18X minus 16X is 2X. Okay, and now here's my variable. I'm down to my one variable. Again, multiplication and addition. So I'm going to do the opposite of PEMDAS and move the 210 over here. Left with 40 equals the 2X. Now I divide by 2. And feel free to rewatch some of these if I went a little too fast or anything. Okay, now we're going to solve an equation again, similar to what we just did up here. We're going to draw the line, and we're going to say, okay, I got an A term on both sides. Move the smaller one. Which one's smaller? The 4A. Now look before it. It's a positive. The reason I know is there's nothing there. So I need to do the opposite of that positive. I'm not looking at this. I'm looking before this. And it's going to be a negative 4A. Negative 4A. So now those are gone. I got 7A minus 4A, which is 3A minus 17 equals the 1. All right, now again, opposite PEMDAS, so I'm going to add the 17, because again, I'm going what's before it. And I'm left with 3A equals 18. 3 times A, divide by 3, and A is 6. All right, 11 is probably the most complicated solving problem you've done up to date, but nothing you can't handle. But you should see these parentheses, and since you can't reduce what's in there because there's a variable, you need to use your distributive property, your little spider legs. So again, we're going to do 3 times 2x, which is 6x, minus, I'll put my minus there, 3 times 1, 3, plus the 5, equals, again, we're going to do the spider legs over here. So 6 times x is 6x, put the plus here, 6 times 1 is 6. All right, combine like terms. So we're going to look over here. We got 3 terms. These are like. So I've got a negative 3. Subtracting is the same as adding the opposite. So I got a negative 3 and a positive 5. So I have 6x plus 2 equals 6x plus 6. So again, we've talked about getting the x term over, and what do you notice happens? They're the same, so it doesn't matter how you view it. When you subtract 6x, you're going to be left with 2 equals 6. What? 2 equals 6? Not in this lifetime does it equal 6. And so this, because this statement is completely false, the x's have fallen away up here. That doesn't happen often. That only happens when you have the exact same number of x's you're subtracting. When you get a false statement like this, that means no solutions. There are no answers that'll make this true. That's my answer. If this said 2 equals 2, well, that would be a true statement. 2 is equal to 2. And that would be all solutions. All right. So definitely one of the tougher ones there. You may need to rewatch that. This is also tough for a lot of people because there's 3 variables here. Let's just do a little change up on the color. Let's go for a little purple. Got 3, Q, X, and P. You got to make sure, first of all, you see what you're solving for. Circle it so that you don't lose track of it. I need that alone on the side of the equal sign. When this is by itself, I'm done. You'll never know the numbers for these. These will stay Q and that will stay P. But I have to get rid of this P because that's with the X and I want the X alone. So again, you have to think, I'm dividing X by P. What's the opposite of dividing by something? Multiplying by that same something. Okay, so P over P cancels off. And you're left with your X, which is what you wanted. Yay! So what's over here? P times Q. So not a ton of work, but again, confusing because you're seeing all those letters, which people don't always love. We have another one to practice with a similar thought. We're solving, and there's again 2 different variables, and we're solving for which one? Y. Let me get a different color. I don't like that one. That bothers me. Let's go back to pink. It's not contrasting enough. So I'm going to circle the Y because that's going to just stay put. Okay. The only reason I would ever move the one that they're solving for is if the Y happened to be in the bottom. Then I would have to end up moving it by multiplying. But as long as it's not in the denominator of a fraction, you just leave it. All right, so again, opposite of PEMDAS, we do the add subtract first. And I see that this term right here is being added. So I'm going to get rid of that. Let's get that white out. I do not like that because that looks like I'm dividing. I'm not. So 3x is being added, and it's a positive 3x being added. So I'm going to subtract 3x from both sides. So I have a 7y equals, and now these I cannot put together. Those are not like terms. So I'm going to put the x term first, plus 2. You don't have to. You could put 2 minus 3x and it would be correct. And then the last step is I need to do the opposite of multiplying by 7, which is dividing by 7. And you can just do that in one fell swoop. So my answer is negative 3x plus 2 all over 7. All right, then we got to proportions. I really hope you've got proportions down well. A proportion, remember, is a fraction equaling another fraction. And cross products, or there's 2 ways this one you could do. You could look at this and say, oh, 2 times 2 equals 4. That's slick. So 3 times 2 equals 6, and you're done. Now that only works when this comes out nice and even like that. So cross products always works. One moment, please. All right, so how are these 2 different? Are they both proportions? Yes, fraction equals fraction, fraction equals fraction. The difference is the b is independent up here, it's solo. The variable is all by itself, whereas over here the variable has something else with it. Okay, so it does add just a little bit of trickiness to it, but not too bad. So we're still going to do the same process. Could you do that like we did here, times 2? You could actually. 2 times. It's going to get a little tricky, so I'm not going to even go through that way, but we're going to cross multiply. So what is 30 times x? Just 30x equals, I usually put the number before the variable. And now here's where you got to be careful because it's 2 and everything up here is really, it's like it's in a parenthesis. So when you multiply, you're really multiplying 2 times x minus 4. So what do I have to do then? Exactly, the spider legs. And now I'm getting in the way of my other lines there, but I have 30x equals 2 times x, 2x. Drop my subtraction down. 2 times 4, 8. Yay, the parentheses are gone. I just have to solve. But again, look at this. I've got variables on both sides. So I've got the 30x and I got a 2x. So I'm going to move this term, the smallest one, the whole 2x, over here with this term. That way 2x minus 2x is 0. And I'm left with just the negative 8 over there. Don't forget the negative. And over here I have 30x minus 2x equals 28x. Remember, the x's don't drop off unless you have the exact same number in the front. Okay, now these are multiplied. Here's my variable. I got to get it alone. So I'm not going to divide by the 8. That's not going to help me. I want to divide by what's with the x, the 28. And now don't lose your negative again. And I also have to simplify because 8 over 28, for one, they're both even. So I know I can for sure divide by 2. But I think we can also divide by 4 up there, can't we? If you divide it by 4, you get 2. And 28 divided by 4 is 7. So there is the full credit answer. Negative 2 7s. Okay, and then we're going to wrap this up with my two very favorite problems. Well, actually, I shouldn't say they're both my very favorite. I'm just going to be honest and say this one's my very favorite. The flagpole. So a flagpole casts a shadow that is 75 feet long. All right, so draw your cute little flagpole. Stars and stripes waving in the wind. There we go. And let's see, what's the 75 flagpole? Oh, the shadow is 75 feet. So here's my shadow. 75 feet. That little slash there means feet. At the same time, a 6 foot tall Mrs. Silva is over here. And you know me, I always have a big smile. And I'm 6 feet tall, so we'll put a 6 there with a little dash for feet. Casts a shadow 9 feet. Whoops, I don't know why I'm starting to use. First of all, that's way too long if the other one is 12. So let's just make that a little bit more realistic. That's not even close. Okay, let's just temper that down. All right, forget it. 9 feet. Question is, oh, 2 verbs, write and solve. Got 2 points coming in here. To find the height of the flagpole. That's my variable. Put it in there. So it's like you have triangles, basically, because you can think of that hypotenuse there, and these would be like your little right triangles. Not that that matters right now. But you want to set up a proportion. So you know when you have a proportion, you have a fraction equals a fraction. So I'm going to start with the one I know, x. So the height of the flagpole. So I'm going to put the height on the top. I'm going to put the shadow on the bottom. So the height is x over its shadow. So its shadow is 75. Then I go over to the other triangle, and I'm going to put the height again on top. The height is 6 feet of myself, and my shadow is 9 feet. That goes on the bottom. There is a slightly different way you could have set them up. You could have went x over 6 equals this over this, and it would still work out the same. But this is probably the clearest way to think of it as height over shadow, height over shadow. Then we have to solve just like we did when we had a proportion up here. You can either multiply, but in this case we're going to actually use our cross products. So x times 9, I'm going to write it with the number first, is 9x. 75 times 6. 75 times 6. 0, 3. 42 plus 3 is 45. So 450. I've got 9 times x, so I'm draw my line, circle my variable. Divide by 9, and x equals, well, I know 9 goes into 45, 5 times with an extra 0 there. Don't forget your unit, it is feet. So you can put the little slash, or you could write FT or FEET. All right, so the triangles are here are the same. Just make sure you're lining up similar sides. So I'm going to just say the large triangle over the small. Wait, I got to go back and make sure I answered both of these. It just dawned on me. There was two things. Remember, did we do both? Did we write the proportion? Yes. Did we solve it? Yes. Okay. So there's a reason we're circling these verbs. We don't want to forget. Okay, so I'm going to do large over small. That's just a reminder for me. When I write these letters like this, that's just reminding me what I'm doing. I'm not actually using it in the solving. So large over small. Okay. So let's see here. I want to make sure I include the x. The x is my small. So I'm going to just put that in right away, and I'm going to put it in the place of the small. What side is corresponding to the small? It looks like this one. But I'm going to make sure by looking up here, SU. So SU is the same as MP. Yep. Good. Then we got to go and we have another set, and this set should have the numbers. So I'm not going to pick these bottom ones with no numbers. I'm going to go to the large triangle and pick this other side, 6. And then I'm going to go to the small triangle and pick its corresponding side, which I'm assuming is 4, but I'm going to make sure MN is the same as ST. ST, yep. Yay! So we've got that. We have to find the value of x, it says. So we need to do our cross products. So we have 6 times x equals 14 times 4. And that's 56. Last step, we're almost done. Circle the x, divide both sides by 6. And let's see what that comes out to. 6 goes into 56 how many times? 9, because that's 54, and then there's 2 left out of 6. So that's 9 1/3 centimeters. There we go. So if you chose to leave it in improper, that would be okay, but you would have had to simplify that down, because I can see that you can divide them both for sure by at least 2. And I think that's it, yeah. All right, so make sure you study these. Go back, rewatch any that you still had trouble with again. Try them, watch it again. Do it until you get this. And you should do magnificent. All right, bye for now.